Okay, so today we're going to talk about how to name acids. So out of this whole unit, I think this is probably the most involved lesson of the unit, but it's pretty easy. The first part of the unit is easy, and then tomorrow's lesson will be like the easiest thing you'll learn all year. And then there's this. So there's 3 different rules you need to know before you go into the test. So you need to know these 3 as far as how to name acids. So basically, if the word, if the name of the acid has hydro, blank, and ic, that means that the word, the previous suffix was "ide." If the word roots look like this, or not roots, the suffix look like this, then this is what the word used to end in. And same with this one. But basically, acids are anything that have the hydrogen as the anion. The cation. The cation is the positive part of the element, and then, the molecule. And then there's this second part, the anion. And so acids will always have the hydrogen in it, and the anion will be what will be used to name the acid. So we will have the hydrogen and then something. It could be any of these nonmetals in the periodic table, or any of these negative polyatomic ions, any of them. So today we're just going to go over quickly how to name acids, and we will use these 3 rules as a guide. So we'll go with the first example, hydrophosphoric acid. So when you get a name of the acid, you have to write its formula. So we know for sure it's going to have the H plus ion. Always. We can go ahead and write it here and here. If it's an acid, it has an H plus ion for its cation, which just means it's positive part of the, it's not an ionic bond, but it behaves sort of like one, so we're going to leave it alone. In 10th grade, we'll just say it's an ionic bond. But it's not, it's an acid. So we're going to look at this word. So hydroic acid. So we're looking at this. So we have phosphor. So is it phosphor? Is it phosphide? Is it phosphate? Is it phosphite? We don't know. We have to find out. Look at what the acid name has in it, and then we're going to use this as a guide. So hydro blank ic acid. So hydro blank ic acid, that means the ending ended in ide. So it was originally phosphide. Okay, so ide, that means that it's just this, phosphide. This is phosphide, right? Phosphate is on the polyatomic ion sheet, just like phosphite, these 2 down here at the bottom. But we're talking about phosphide, so that's easy. It's just P, and this has a -3 charge. So P with a -3 charge. And then that's it. So this is a +1 charge, that's a -3 charge. We bring these down, and that's our answer. The answer is just H3P. So if you think about it, there's always only going to be one anion in any acid. And that's because hydrogen has just a +1 charge, and we use the same cross method to find its formula. So you always know that you won't have a number here because it should always be 1. The only number you have to worry about is how many hydrogens will balance out that negative charge. And in this case, it was a -3 charge, so we needed 3 hydrogens to balance it out. Okay, chromic acid. So we have ic acid. So that's this one, ic acid. So the original ending was 8. So for sure we know it is a hydrogen ion. And chrome, so it was chrome 8. Okay, the ending is 8 because it was ic. Chromate is Cr O4 with a -2 charge. So you just bring these charges down, and your answer, H2CrO4, that's your answer. Okay, and then last, we'll scratch this out so we don't get confused. Chlorus. So the ending is OUS, acid. So OUS, acid, that means it ended in ITE. So if it was ITE, it's chlorite. So it ends in ITE, not ide. If it was chloride, it'd be here, but it's not. It's actually on polyatomic ion. So we have to find it here, chlorite, which is here. So ClO2 with a -1 charge is what chlorite is. Always it's a +1 charge. And then we have ClO2 -1 charge. So it's a 1-to-1 ratio, so you don't have to have any subscripts at all. So that's your acid, that's chlorous acid.